Good morning. All right, so today we're going to start on 3.1. Investigation 3 is about inverse variations. Inverse variations, they're in our everyday life. They're common, like when you see questions about area, if different dimensions of different figures, but they all have the same area. More particular, y equals k over x is one form of the equation, constant other than zero. All right, so you can never have zero in this equation. In this situation, you'll see y. Or another way to look at it is y times x equals k. For instance, this is another one that is common. Speed equals distance divided by time, whereas speed times time will equal distance. Okay, that's a common real life scenario where you see it as well. First things first, this will look just like one of the examples in today's work, and I'll do another example to relate speed and distance and all this stuff. The area of a rectangle is 36 inches squared. Find as many different dimensions as you can of a rectangle that has the same area. So you're going to pretty much be doing this. You got your length, okay, you got your width, and we're going to come up with, we know that length times width will always equal 36. So like length times width will always equal 36. 36 is our constant, it's never going to change, that's always the area. Let's find how many different lengths and widths we can find and multiply to 36. We'll always do the easy one, 136, that works there. Let's do 218, okay, keep going. 3 and 12, and another one, 4 and 9. Now on the flip side, the widths and the lengths are going to switch around a little bit, okay? I know that if I have a length of 9 here, I have a width of 4 here, so on and so forth. So then I also have 12 here, I have 3 here. These are all valid. I have 18 here, I have 2 here, and I have 36 here, I have 1 here. These all multiply, they all multiply to the same exact area of 36. Now, when I go to graph this, okay, bear with me, I'm just worried more about the shape than anything else, okay? Let's call this 5, 10, 15, 20, 25, 30, 35, 40. 5, 10, 15, 20, 25, 30, 35, 40, okay? Call this length, okay? Call this width. Remember, always title your axes. I'm going to get crazy about that. So again, we're just ballparking it. We're just showing you the general graph, how it looks there. 218, 5, 10, 15. So 2 is right about there. Who knows? 218. 3 is still underneath this. 5, 10, 12. Right about there. 4, 9. Right there. And then 9, 4. Right about there. Okay. And then as you see, we got 12, which is 3, so that's right about there, and 218, that's right about there, and 136 right about there. Your graph should look like this. Your graph will never touch the x or the y axis because think about it. We can never have 0 times anything equal anything other than 0. That's why your graph will come really, really, really close to, but never actually touch the x or the y axis in these particular situations. I'm going to come back with another example and we'll get started there. All right, so we are back. So another example is relating to speed. Speed is distance over time. Average speed is distance over time. And again, here's the example. It looks very similar to the other problems that we're doing today as well. This is just a corny made up one. It says the distance between Weber's house and his cottage is 300 miles. Let's be clear, I don't have a cottage. I'm poor. I teach. So here we go. We got this. Here's my situation. Again, made up completely. I got a car situation, probably made a stop for some snacks and whatnot, maybe at lunch. Took a plane. Again, I don't know who would fly 300 miles, but there are some people that would do that. But maybe the plane, again, plane got delayed, 2.5 hours it took. Train took 4 hours, and one day I felt crazy. I thought I'd bike there. Again, totally made up. 16 hours. So Speed is distance divided by time always. So being that I set these up, feel free to go ahead and do that. Copy this down in your notes so you have something for yourself. And 300 divided by 6, that's going to equal 50. I don't know why I used my calculator, I knew that. Now I'm going to, so this is my miles per hour. So you guys have been around inverse variations a lot. You know them, you just don't know you were using them. 300 divided by 2.5 equals 120 miles per hour. Makes sense, you're flying at a faster speed. 300 divided by 4 is 75 miles per hour, and that's consistent with a train. And 300 divided by 16, wow, I was traveling 18.75 miles per hour. All right, now we are going to graph this data, and it's supposed to have a curve to it because it's inverse. All inverse variations have that little curve to them, okay? So we're going to graph, if I'm asked, like I'm asked the side, plot the data, draw the graph. So we'll draw the time and the average speed, okay? Time and the average speed, these are the two variables that are changing constantly, so let's do this. I will put the time down here because that's my independent variable, and my average speed on my y-axis because that's my dependent variable. And I can go up to 16, so let's go by twos. 2, 4, 6, 8, 10, 12, 14, 16. You can all see that perfect. And this goes up to 120. Let's go by tens. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. All right, so we'll do this one first. 50, so let's just put this data next to it so we can all see it and then not mess anything up on accident. We do a list like this. And we got 50 right here, we got 120 right there, we got 75 there, and we got 18.75. All right, so car is 6. 6 is right here, 2, 4, 6, and 50, 5, 10, 20, 30, 40, 50, 10, 20, 30, 40, 50. 2.5, 120. 2.5 is right about here, 120 is way up here. And 4, 75, 2, 4, that's 50, 60, 75 is right about there. And 16, 18.75. We already know this is 2, 4, 6, 8, 10, 12, 14, 16. And 18.75 would be right below the 20 marks, or right about there. You can see that. And what do you know? We got ourselves a nice little curve. Just like we predicted, because this is inverse, okay? This is what you are doing today, and it's going to be worded just slightly differently, but know that a curved line is always an inverse variation. Y equals k over x, so this is true for this right here. Your constant was the distance, it never changed. The speed constantly changed as your time increased, which makes sense. So I will see you, oops, put this down, sorry about that. I will see you guys in today's class.